Hey everybody, Mr. Regan here, and for today's video, we're going to be looking at the diagram in task 5 that you see here, along with explaining some of the important scientific ways scientists figure out which common ancestors are related to different descendant species. So if you remember from the last task, you guys looked at how these evolutionary trees show a relationship between our common ancestors, the population that came before, our descendant populations and species here. So we know there's some organism that came before our whales and our humans that we are all related to. But at the end of the video, we talked about how there's a limitation to this diagram, meaning this diagram shows the relationship, but it doesn't really explain how or why they're related. And more importantly, it doesn't explain how or why scientists have come to this conclusion. Part of the evidence that we as scientists use to explain who's related to who is by looking at the chronological order at which organisms show up on our Earth. In other words, we use what you see here, which is a simplistic version of the fossil record. And what this really is just a cutout of the ground in which scientists would look at to determine when organisms were around and how old certain organisms are. So if we're looking at this diagram here, we're going to imagine that the very top here would be the top of our Earth's core, our Earth's crust, excuse me. So this is where all of the humans are. This is where all the animals are. This is where all the plants are at the very top layer. And then at the very bottom here that we see, this would be the core, Earth's core, okay? So if we're thinking about it, this is just a small cutout core of what would be a section of our Earth. And as we read this diagram, you'll know that we have different layers here of rock sediment, okay? Meaning different compositions of different soils and rocks and things as well that happened at different times. And that within each sediment, we have different fossilized organisms or parts and pieces of fossilized organisms. Now, the fossil record here helps us to understand the order in which organisms showed up on our Earth, okay? And when we look at the diagram here, we're able to notice a few things. Number one, we have very unique organisms happening within different layers of our fossil record. And number two, that we can also figure out which organisms are oldest and which organisms are youngest based on where they are in the sediment. So thinking about the very top of our fossil record here being where we would be, okay, and the very bottom being where the core of the Earth is, the question we're looking to answer is which fossils in the diagram are the oldest and which ones are the youngest, and how do you know? So when we look at our record here, we have 3 sets of fossils that are occurring, and you need to ask yourself which one are the oldest and which ones are the youngest, and how would you explain that? How do you know that? So we as humans would stand at the very top here of the Earth's crust. The core is here. We have our different layers, one on top of the other. Which one of these do you think is the oldest? Which one do you think is the youngest? Explain your thinking. If you think your answer is correct, move on to the next set of slides. If you have questions or you want to clarify things, check in with me. Otherwise, good luck.